Hello. Hi, everybody. Welcome to today's episode of The Golden Path to Spring One. Hello, Marco.
Hi, Cora. Hi.
Nice, nice to see you here. Thanks for presenting on our series. We're really
Thank,
really honored to have you.
thanks for having me.
Of course. So my name is Cora Iberclyde. I'm a developer advocate here at VMware, and really it's my pleasure to host Marco today. So, yeah, Marco, tell us a little bit about yourself first.
Sure. Yeah. I'm Marco. I come from Munich, Germany. I work in Munich, Germany, and I work for JetBrains, so the makers of IntelliJ IDEA, or hopefully your favorite IDEs.
Yes, and my
And
favorite.
and yeah, I mean, as my job, I'm a developer advocate, so I cover topics mostly in the JVM space ecosystem, and convert them to videos or guides or in text form. So hopefully you've seen or read something from me along the way the previous years.
Yeah, I've seen your YouTube channel. That looks like a lot of fun. You definitely seem to be quite dedicated and put a lot of
Yes,
energy into it.
we're trying hard.
Yeah, yeah, I recommend. Yeah, the Marco Coast channel. I recommend all of you check it out for sure. How long have you been doing developer advocacy, Marco?
For JetBrains now, it's my third year almost. So yes, and before that, I mean, I guess I've always, tried to. Maybe I've always done it. I've been working as a developer for a long, long time, but I've always tried to help my colleagues, with stuff, not just with tooling, but with concepts, with learning material. So I don't know. It's been a long time, I suppose.
That's interesting. I think I've been doing advocacy for 3 years now, and I feel similar to you that it's the kind of thing where if you've probably been doing it for longer because you like to explain, you like to teach, you like to help people, and then suddenly you find out that you can do that as your job, and yeah, that thing you were doing on the side becomes your full time
Absolutely.
task.
That's the way it was. Yeah.
Yeah, that's cool. Okay, so I don't want to take up too much of your time because the stage, you're center stage today. So just to everyone joining us, I'm going to hand over the stage to Marco shortly. We're going to take questions at the end. But throughout the whole talk, feel free to put in comments, chat amongst yourselves, and I'll go through later and find all the questions from Marco, and we'll go through them. And then, yeah, Marco's going to tell us all about why you don't need to worry about scaling your Spring web app. He's going to take a weight off your shoulders for all of you who've been stressing about that. So, all right. Last time I hosted, I didn't quite get this fully right. So Marco, hopefully I get this right. So I'm going to add your slides first. And then I'm going to go away. And as soon as I go away, you can start. So Marco, the stage is yours.
Thank you. Bye-bye, Cora. Right. Hi, folks, again, from my side. So yes, what a long title. Why you don't need to worry about scaling your Spring web app. Now, how did I come up with this talk? I don't know about you, but in the past, I did a lot of, consulting work and build new products. And there was this point when we built something new, and then, a business person came in and at the end of the day said, well, is this thing going to scale? What happens if tomorrow 10,000 users come? Or what if we're going to be the next Amazon? And the thing is, I never had a good answer. So, I mean, obviously, you always have this kind of guess where you could, mumble something along the lines of, we have auto-scaling, Kubernetes pods and whatever. But I wanted to have some good old data, to back up my claims, that, to really understand that if I have, my monolith working on a machine, how powerful would that machine have to be? How cheap could it be? How expensive could it be? How many users could it handle? And having good solid data, answering all these questions. And just to show, this is, by the way, going to be almost a no slide talk. So this is the only slide I've prepared, almost the only slide I've prepared. So I'm just gonna quickly leave that here. But what I wanted to show you, people who are used to Amazon AWS, for example, you might know that page. Whenever you boot up a machine in Amazon EC2, you're bound to choose the instance type. So of what instance, how many CPUs, memory, what price, should that instance have, where you want to deploy your application to. And when you look at that page alone, here on the left side, you can see there's a couple of categories, and I'm on the general purpose category. And now it gives me the option to say, well, if you want to boot up a machine, it could be type M7G, Mac, M6G, M6i, M5 something, M4 something, T4 something, T2 something. That is just general purpose. And when I click computer optimized, I go from C7 down till C4 here on the right side. Memory optimized, R7 to Z1D. So every combination of the letters and the alphabet numbers you have here on the instance type page. And I was always confused. Now, what should I choose? And this is how this talk came along, answering those questions. Now, I thought, back when I started preparing for this talk quite a while ago, I thought that I wanted to have a chat with some people who might know something about scale. And in the Java world, we deploy, everything with Tomcat and Jetty most of the time, or oftentimes, let's say. And I got in touch with the Jetty maintainers who write Jetty because they have quite a couple of answers on Stack Overflow where they talk about scaling and insanely scaling Jetty instances where they handle, thousands, 10,000s of users, 100,000s of users. And I thought they know a thing or two. So this is just my shout out to the Jetty maintainers, because a lot of knowledge I got for this talk is actually from them, and I'm reusing that knowledge. But right, so without further ado, what are we going to do now in this talk? To answer the questions, how much my Spring application can scale, we're going to do a bit of load testing, and we're going to talk a bit about performance-aware programming and a couple of other things together. But first off, we're going to start with load testing. And that means you will have the pleasure to have a look at my nice handwriting now for a while, because I want to draw a tiny graphic of what we're about to do first before we get into the nitty-gritty of the coding. Right. So we're going to start with a very simple scenario. We're assuming we have a Spring Boot web service. It's not going to be a microservice landscape for now, because all the concepts which I want to show you, first of all, we need to understand with a single tiny box, and then we can apply all these concepts to, a whole microservice landscape. First of all, let's concentrate on one server. So we have this one Spring Boot box here in the middle. Actually, let me just show you the code, what this one Spring Boot box does. I have it here. The Spring Boot box, or the machine, it's a Spring Boot 3 application. It is one REST controller, which returns JSON. And I call it a text controller because it returns a text rate object. And the text rate object consists of, a name and a rate, which is just a double. And the name is German VAT. And the rate is always random. So it's a random number because I wanted to have a bit of CPU work done in this controller here. And that is literally all, this tiny REST service does at the moment. It's a bit of a bogus, REST service, but it, will teach us the concepts quite well. And we'll actually have a look at all the same concepts in relation to Spring Pet Clinic also in this talk. Right, so this is our text controller, and we have that. Now, this machine or this application is deployed somewhere in AWS already. What else do we need for our load test to figure out how much this server can scale? Well, what we need to do is we need to have a couple of other actors in here, and I call them loaders. So with a big L here, these are 4 machines at the moment, and their only job is to generate some load. They call this REST endpoint that you just saw. And the reason we split them up into 1, 2, 3, 4, 5, 6 loaders is because it's relatively easy for the loaders to become overloaded, and then we don't really find out, how much load the server can take. So, I just split them up into 4 loaders. A tiny thing that Jetty maintainers taught me is, and I'm quite sure that everyone has done, some sort of load testing before in most projects. So it might sound a bit like a tiny basic review, but fear not, stay with me for a second. I will make it more complex in a minute. The loaders, in my load testing scenario, they only create loads, so they send off requests, but they don't record response times. For that, what we have is a tiny machine which is called probe, And the probe is essentially a loader, but it only sends 1 to 2 requests per second. It simulates, one user, making requests to the server. So over the course of the load test, the probe sends these requests and records response times. The loaders, they send the requests, like thousands of requests, but they don't record the response times. That is something is debatable, but it's something of some sort of a best practice I learned from the Jetty guys to split these responsibilities. Right. Okay, that was enough basic talk. Or rather, let me one more thing. What we will do is we will run several load testing scenarios, and then we'll see how our Spring Boot application will behave. And let's say the first load testing scenario, we want to send something like 250 requests per second from each loader, which means we're going to be sending 1,000 requests per second onto our Spring Boot application. And we want to see how it is able to handle those requests. And let me actually just go to a project I prepared, and you'll see the source code for the project, the link to all the sources I'm using at the end of this talk. There's one test class. Because I'm not using JMeter, I'm not using Gatling, I have pretty much let's say a low-code, one long class here, which also includes a Jetty load testing framework, which the Jetty guys also wrote. We don't need to worry about the the content of this file now for now, because literally all it does is it boots up for loaders, it sends the requests against this server that we saw on the picture, and we have 2 variables here, or actually just one variable we need, this one here. And it says, hold on, let me just run this test now. It says every loader sends off 250 requests per second, and times 4, it will mean 1,000 requests per second. And I'm running this test now already because it's going to take, I don't know, 2-3 minutes to finish. And I want to rerun it a couple of times. So I need to switch back and forth, unfortunately, once or twice to my IDE because I want to get the test results back just in time. So I just started the test with 1,000 requests per second in total. Right. Now the test is running. I can go back to drawing mode. Drawing mode means we're going to start with 250 requests per second, so 1,000 in total. Then let's add it up to 1,250, right? Which means 5K in total. And then we are going to do something like 3,000 requests per second. So we have 12K requests per second in total. And then, by the way, I want you to already think about it. Do you think that this machine will handle the 12K requests per second easily? Do you think it will handle 24K requests or even more requests per second? I should have told you that, by the way, this is an M5 machine, which means it has 4 CPUs and 16 gigabytes of RAM, I think. So it's a pretty beefy machine. Just, guess what do you think this machine will be able to handle with this endpoint. All right, so what we have now is we have our load testing scenario, which is all nice and dandy, but there's a fair amount of stuff missing because just with the load test itself, and that is a very straight line, as you can see, with the load test itself, that doesn't help us too much. We're now generating we're generating load, but what are we actually measuring? How do we find out what specific parts of the Spring Boot application, will scale or maybe have issues, under pressure? How do we find that out? We need to collect some data. What data? I'd like to split it up into 2 big categories. The first one I would call the big picture or operating system data, meaning that during the load test, I want to understand, hey, how is the CPU saturation of my server, of my loaders, of my probe? I would like to know, what about memory usage of all the participants, right? Was there a problem suddenly that my server uses 5 gigabytes of memory and whatnot, that sort of stuff? I would like to get data on the network usage, understanding how much traffic does my server actually receive and how much traffic does it send out. I would like to get data maybe even on I/O usage, where I would find out, right, if I have a hard drive, for example, and an application which writes or reads many files, how saturated is actually my disk, this sort of stuff. And that's what I call operating system big picture. It just gives us a general overview of, where is my server or where are my loaders going. Number 2 is we need application-specific data. Application-specific. Right. My handwriting isn't the best anymore. I hope you can still read it. Application-specific data. This is where things get interesting, because what we ideally would like to do is, I would like to, have some stopwatch times. I would like to, time my business logic. So how long does my business logic take to execute, excluding, for example, all the Jetty specific code or the Tomcat specific code. And actually, funnily enough, these servlet containers, they allow you to just time the code that the business logic needs. So when they hand off the request to Spring, for example, you can time that the whole time. You can time the whole time and find out how many milliseconds or seconds does my business logic take. And ideally, obviously, you would also like to gather additional data, like how many SQL statements do you send? How long do these SQL statements send? Or not just, SQL if you're using a database, but if you're using any external system, you would like to time all of that data, which we don't do here now because it will massively complexify things. But anyway, you get the idea. Then what you also want to do is you want to, and we're going to spend a lot of time with that because it's a lot of fun. You want to have a look at flame graphs, meaning you want to ideally, have an async profiler running. And the profiler can generate data, which you can convert to flame graphs, CPU flame graphs, memory flame graphs. There's a couple of different types of flame graphs. And those flame graphs, they will really tell you, in fact, where your application will scale or where it will have performance bottlenecks. So we're going to spend some time on flame graphs here. You also want to collect data like garbage collection logs. You want to collect some data like, for example, there's a tool called JHiccup, which lets you collect data on, did your JVM stall because there was a noisy neighbor on the operating system or the containers and whatever. So all this sort of data you want to get for the test runs. And to be fair, I was talking now a lot about this stuff, but the left side, I have seen people do, consistently, semi-consistently, splitting up the loaders from the workload from the targeted system. On the right side, collecting all of this data, interpreting all of this data correctly, and then making the right conclusions, I haven't seen so often. But this is what we're now actually going and what we're trying to do, and finding out, hey, how does our Spring Boot application actually behave by looking at this data here on the right side. All right, so that was a lot of talking, a lot of overview. Let's go back to our test class that hopefully is already finished, right? Process finished with Xcode 0. That is great, which means I talked a lot. That also means that I'm gonna, just rerun the test with now 5,000 requests in total, which you can see here. So we get the data in and can have a look at that also in a couple of minutes. Right, so this new test run is running. Then let me show you something. What happens is this long test class, as I said, generates all that data that I just drew. So CPU data, memory data with simple Linux tools. And all the data is being put into text files, and the text files in the end are being downloaded after the load test into my target results folder, which you can see here on the left. And I have two folders inside here. The first folder is a timestamp of the current time, 2015 in my time zone. And it contains all the data for the specific loaders. So I have these 4 loaders, which means I have 4 directories. I have a probe, I have a server. And we're going to have a look inside these folders in a second, and we're going to check the data. There's also a plot folder, which has a graphic combining all the test runs. So once our new test runs are finished, we'll also see them in here. Let me show you what that graphic is like. Just going to quickly open it up in the browser. Right. Okay. So maybe a tiny quick breather, because now we're gonna, spend some time on data visualization. What you see here is an HDR histogram. I know that people take offense with this being a histogram, but in fact, it is an histogram. It's a high dynamic range histogram. How do we read this? So the blue line represents our test case that we just did, the 1,000 requests per second. This you can see here in the legend down below. And on the left side, you see the latency, meaning the response times the probe got during the load test. So as I said, the probe sends these requests and records the response times. And we see these response times here to our text controller. The times are unfortunately microseconds, so not even milliseconds, meaning if you divide them by 1,000, right, then you get roughly, by following the line, you can see, that the response times were between 0.8 and let's say 1.4 milliseconds, which is effectively nothing, right? So the request took somewhere along these lines. That's the y-axis. The x-axis is the percentile. So it's a simple percentile histogram, meaning I can, follow this line here and see, for example, this here is the 60th percentile, meaning that 60% of the requests that the probe made, they took up to 1,020 microseconds, or let's just call it 1.0 milliseconds, right? And when I follow it up here and I go to the 90th percentile, I can see that 90% of the requests, they took like 1.12 milliseconds, right? So the line just gives me a nice little percentile distribution. And this is just one line, and there's not much, not many outliers, whatever. It looks a bit uninteresting, but it's a super, super simple, useful tool to compare these different test runs. And once we approach the limit of our server, we will actually see very different lines, and then you'll immediately know why you want to have these HDR histograms. All right, so that is the histogram for now. Right. There is already our next, there's already our next test run finished, and that's why the page refreshed itself. Meaning what you can see now is, by the way, that the next test run is the red one here, 5,000 requests per second. And here you can already see, well, that literally 90% of the requests, they also just took, 1 millisecond. But then suddenly, there was the odd request here at the very end, that took up to 60 milliseconds of, let's say 30 milliseconds, 60 milliseconds. So it's a bit of a change. It's interesting. Let's see what happens once we crank up the load even more. Let me go back, and I'll just quickly run a performance test again with 3,000 requests. And then we're going to have 12,000 in total, right? So this is going to be running. And while this runs, I want to finally look at some more data. Because, as promised, we're collecting operating system data for every test run. I'm now having a look at the first test run we did at the loader here on the left. And I want to understand just quickly the CPU usage, memory usage, and network usage. And yes, if you used, for example, AWS, you would have, dashboards and graphics and whatever. What I just did here is I made it completely vendor independent, used some Linux tools, and I get the output from these Linux tools here. So the CPU log for my loader, for one of the loaders in my test run, how do you read these tables? I don't want to super confuse you. We're going to make it very simple. So I just take 3 CPU snapshots across a test run, because a test run is 30 seconds for this demonstration. And every 10 seconds, I take a CPU snapshot, which means you see these 3 tables here, right? The 3 CPU snapshots. You can see that my loader has 4 CPUs. And you don't actually have to look at these 4 CPUs for this time. There's an average here, the first line. Summing up averaging out the 4 CPUs. And then you can ignore all the columns. You can simply go to the rightmost column, and it tells you on average how much were your CPUs idle. 97% of the time, 96% of the time, 98% of the time, meaning the CPUs work like 1%, between 1 and 3% to generate the load, which is literally nothing. So just making sure that the loader wasn't overloaded. If you ever saw that your loader had 100%, 90%, 85% CPU usage, you would know, hey, my loader is actually too weak to, generate the load. But this looks completely fine. The same thing with the memory. We have a couple of different snapshots, meaning here we have actually 4 snapshots, 4 tables here. And again, we just quickly see here on the left side, the total available memory on the machine, 15 gigabytes, used 400 megabytes. And for now, we don't really care where these 400 megabytes come from. We just know, okay, much less than the total 15 gigabytes available. So we're actually happy with that. Network log. This is also a nice little graph, and I don't want to, overdo with these graphs. But there's 2 tables now represent 1 snapshot of the network adapter. And so this is 1 snapshot, this is another snapshot, and here's 1 more snapshot. And the only thing that's interesting for us now is the received kilobytes per second and the transferred kilobytes a second. So how many kilobytes did my loader receive or transmit? Actually, for the server, it would be much more interesting to see that, because it would be a higher number. But in fact, the only thing what I wanted to mention is that also your network adapter for the server could be a bottleneck. Usually for business applications and whatever, that is never the case. But with my load tests, I actually tried it out, to get the network adapter to be the problem, which is actually possible. That then packages get dropped, and you need to reduce the whole bandwidth of whatever the server receives. Right, so we have that data, and obviously in a good old load test, you would need to make sure not to check it for every single loader, but for the probe, for the server, and so on and so forth. That is just general load testing. And by the way, that is, again, doesn't have much to do with Spring Boot, but please, if you do these tests, what I did here is I also printed out the HTTP statuses of my loaders. So I'm calling this REST endpoint, and I want to make sure that I get 200 back. This is what you can see here on the right, the status code 200, 200. And I'm sending 250 requests per second. And this is just my visual representation that, I get 250 requests with a status code of 200 back. And I can quickly check the file and see that every request was successful. I don't want to, have a super fast, super performant server, which is only super performant because it returns 400s, or 404s or whatever have you. So that's just a quick check in between. Right. Now we have that data, and let me just double check. We're not going to check the other data for the loaders, because there's not too much interesting stuff here. We have the server, right? And the server also has, as I showed you, CPU memory network log, and it also contains the other data we talked about, profiler data, hiccup data, and performance data. Now, before I check out this application-specific data, let me just quickly see if, right, my load test finished the 3rd one. Let me just see what the graph now looks like. Ooh, look at that. So we're back in our plot. What we can see here is now that, right, so we sent off 12,000 requests per second against our little endpoint. And now suddenly I would say like 75% of the requests, they took less than 2 milliseconds, or about 2 milliseconds. And then, you have the odd request suddenly where you have 250 milliseconds, 300 milliseconds, which is already quite high. And we still get responses back, and the server is responding, but I would assume that the CPU usage by now is already fairly high, at least at some points. And now, actually, the server is approaching its limit. I mean, we can run another, test with 24,000 requests in total. But in fact, the only thing we would see is, another line here, which is even steeper, because the server already has trouble. And at this point, we should stop, because actually we shouldn't do like a limit test and find out, hey, when can we crash our server? But only, understand, what is our server capable of under normal circumstances. Right. So in any case, but it was nice to see that. I would say, the 5,000 requests per second, that is, still kind of okay-ish. But somewhere between here, I would say 5,000 to 12,000, 7,000 requests per second is, where our server gets, real issues. Now, let's go back to our data. Because actually, when we look at the server data, let's do it from the last test run quickly. So I'm here in the new folder, test run, operating system, CPU log. Let's see, by the way, the CPU log, what it says. Aha, the CPU log says, well, the processor on average, is now 60% busy, 70% busy, 60% busy. So it's already fairly high load, right? Which kind of corresponds with the plot, that a lot of requests were still fast, but then there was a lot of work to do. And then, there were some spikes along the line. And let's have a look at the memory that took. Right, so memory usage was 1.8 gigabyte for this test run, 2 gigabytes, which is still it's okay compared to the 15 gigabytes we have, but that increased. And the network usage, we can see the network usage is also but still kilobytes per second. That is far away from 100 mbits or 1 gigabit or whatever have you. Yeah, so that is also not going to be a problem. All right, now, before I bombard you with even more stuff like garbage collection logs and also I said the JHiccup log, I'll show you one more thing. Actually, I'll show you. Let's go straight to our flame graphs, because that is where the juice lies. Does that make sense? Yeah. Let's see. So the flame graph is something I'm making as part of the load test. I'm generating a CPU flame graph. As mentioned before, there's other types of flame graph also. We're just going to focus on the CPU ones in this talk. And if you've never seen a flame graph before, don't worry, because I will walk you through it. The flame graph looks something like this. And that actually might be a bit scary, but for now, please forget everything forget all these fancy colors here, red, green, blue, yellow, and these spikes, because we'll take it very simple one by one. I'll walk you through it. We're going to start at the very bottom. So this bar here at the bottom, the red bar all, tells you all the time the CPU spent in handling the requests for this, simple load test. Remember, we just, we hit this one endpoint, right? And this flame graph represents all the time, all the code where the CPU spent its time, where CPU time was spent, rather. What you can see here is, on the left side, you can see this big green blob. The green blob is actually our application code. That means our Jetty, our Spring Boot application, our own code that we wrote. Here on the right side, the yellow block is JVM internal stuff. That is, in fact, our just-in-time compilation, the C2 compiler, and we can actually safely ignore it here. This whole thing on the right side, yellow, we can ignore it. The red lines are native calls, so asking the operating system, for example, hey, operating system, please start a thread, please, create a network request, that sort of stuff. So you talk to your operating system, the red lines. And the orange lines is kernel codes. So you actually also find out where your kernel, wasted, so to speak, CPU time. And please do note that you don't get, specific times like cycles or whatever that your CPU spent. What you see essentially is percentages. And we know that, my CPU spent 100% of the time. And from the 100% of the time, where was most of the time spent, so to speak, the sub parts of these 100%? Where do they come from? And when you look at this flame graph here, and when you hover over these stack traces, effectively, these are stack traces, the ones you see from debugging code, you also see a percentage saying that when I look at thread run here, it says that 80% of the time, CPU time, was spent in thread run. Why in thread run? Because Jetty essentially runs threads all the time to handle your requests, and that is why here at the bottom, thread run, takes up most of the CPU time. And when you go up here, you can see the packages starting with Eclipse, Jetty Server. You go up here, and then suddenly you arrive at Spring Framework. This is where Spring Boot comes in. And then you go up here, even more Spring Framework code. And then the question is, hey, where is actually my text controller? And the funny thing is, you can search inside these flame graphs. So I'm going to search for text controller. And I don't know if you just noticed something, but what actually happened is something turned purple, my text controller here. And when I hover over my text controller, I can see that there's a tiny percentage. I'm not entirely sure if you can see that now on the screen because it's very tiny, but it says that 0.84% of the time, CPU time, was spent in my text controller, which is basically nothing. My code that I executed didn't waste any CPU, so to speak. Most of the code, most of the CPU was spent in Jetty, and then in Spring Framework handling. And by the way, we can drill down a bit deeper because we can say, hey, let's start with this here as a baseline, right? And then we don't see the bottom of the stack trace anymore, but just the top. And then when we go up, you can see that the Spring filters, once per request filter, framework servlet. This is where the Spring Boot handling begins. And then you can see here on the right, this is here my text controller, text rate. And here on the left, you can see that a fair amount of time is spent in JSON, meaning that my objects are being converted to JSON strings. But with a fair amount of time, I mean like 7%, my flame graph tells me, which is also not too much. And bear in mind, 7% of the total, including the just-in-time compilation whatsoever. So yeah, there's really not much CPU work being done here. By the way, when I look at my text controller rate here, then I can see here's my text controller.textRate method. And even here, I can see where's my CPU spent. And remember, we're generating a random number, and that's why almost all the time here in this method is spent in random.nextDouble, just generating a new random number. And by the way, for the inclined people who still remember what red and orange is that generating a new number actually also makes operating system calls, and it asks the underlying operating system, hey, can you help me generate a new random number? These are the red lines here, the read bytes, and the kernel code. It's interesting to see how this influences the whole that you can actually see the entire stack trace across the whole operating system with flame graphs. All right, so this was my basic example of my Spring Boot text rate controller. Let's switch it up a tiny bit. I deployed Pet Clinic locally. And you might know Pet Clinic. It's the basic Spring Boot application, so to speak, a demo application. And there's an endpoint, a veterinarian endpoint, where you get a list of 5 vets from a database, and you display them on this nice little tiny HTML page. Now, before I did a test run against a couple of test runs against this endpoint, just like we did now that the last half hour. And before I show you the flame graph, I just want you to give what would your idea be of where the CPU time is being spent. So this stuff here, the vet's homepage, the vet controller, it actually tries to query a database, but then it caches the results. The database in any case is H2 in memory. And so once I hit this vet endpoint, where do you think the CPU time is, most CPU time is being spent? Well, let's find out. So I'll go back. I have a folder here, results Pet Clinic. And let's have a look at the plot first, by the way, because the plot is interesting. The plot shows me that, I did a test run with 700 requests per second. So 700 requests is a lot less than that we just did with our text controller. And then you can see here that the microseconds are in the millions. meaning if you divide it by 1,000, you have milliseconds, so 2,000 milliseconds. And then by 1,000 again, you have seconds. So you already, when the load is 700 requests per second, some requests already take like 2, 4, 6, 8 seconds, which is a bit of a crazy number. And I thought, well, how can that be? What makes the application so slow with the rendering this HTML table? Well, when I look at my server data and the operating system data, for example, and I can see that at times here, upper right corner, the CPU was busy 90% of the time, or 75% of the time. Here it was, better again towards the end of the load test, but the CPU was actually for some time during the load test fully smashed. There wasn't much more room, for it to do something else. Now, what could the culprit be? What could be the problem? Let's open up the flame graph. So I'm opening up the flame graph. And again, what we can do is ignore the right side, just-in-time compilation. We only want to, have a look at the left side, which is our application code. So we can see that, thread run, the Jetty server, when I scroll through the packages, Spring framework then suddenly starts. And then, by the way, let's do another search. I know that in PetClinic, it's called vet controller, which is the controller, again, which tries to fetch the data from the database. And I can see, again, it turned purple here on the right, that my vet controller, which caches, these results from the database, used up 0.68% of the CPU time, which again is nothing. So that controller method isn't the problem. But when you look at the left here, then you can see that here's a dispatcher servlet to render. And then the bar immediately goes to timelyview.render. And then you'll find out that actually all of this time here, this whole block here on the top, is spent inside timeleaf, processing of the template and making sure to render these 5 these 5 list items. And the gist of it is that I don't want to diss timeleaf because I've used it, actually a lot in past projects if I built, HTML based backends, but it's also somewhat slow, or rather it uses a fair amount of CPU. And what I did is for this talk, and unfortunately I didn't, prepare the slides, I replaced the exact same templates with FreeMarker just out of interest, and to get the exact same layout and website. And by that is, by the way, when you look at it, when I hover over timeleaf, I see that roughly 40% of the CPU time is spent in timeleaf. 40% of the CPU time. With FreeMarker, it's about I don't remember quite correctly anymore, but it's like 10 or 15%. And the machine at 700 requests per second, is breathing just fine. The CPU usage is much, much, much lower. And it's interesting how, when you think about scaling a Spring application, that there is no, Spring application. A Spring application consists of, you have Spring, let's say, basically the dependency injection and, these, let's say the entire infrastructure. But then you have, Timely, for example, when you want to the templating language library, when you want to build front ends, you could have JSON or XML conversions. If you just do REST services, for example, you have obviously database stuff, Hibernate. You have your own business logic in between. You have 20 million other libraries, and there can be so many tiny parts and pieces of the puzzle which waste CPU or which waste or leak memory, that just thinking of scaling a Spring Boot application doesn't even make sense. You need to understand where specifically is the bottleneck, where specifically are the problems, and when you crank up the load, which puzzle pieces actually have problems under stress. And Timeleaf is one of them. Well, I was surprised myself to just understand that parsing and rendering these templates actually does sometime. By the way, the templates are cached. I double checked that. So Timeleaf caches the initial parsing of the template, but it still takes some time or CPU time to render them. All right. So now that we have that, let's go back with the flame graphs. Actually, let me show you. if there was any other data I wanted to show you. No, operating system, profiler, garbage collection logs, JHiccup, I said we're going to leave out. Performance log, we're also going to leave out. I think it was enough data for now. Because, in fact, just as a quick recap, what I would like you to take away is when you do these load tests and you make sure the setup is correct, that you separate loaders, server, and so on and so forth, that then you need to collect all this data and you need to be comfortable, interpreting the data. And that flame graph, for example, is super, super useful tool, which tell you inside out, where is CPU, memory, and even thread time when you have, IO heavy related waiting. For example, when you do many requests to other services, you can find out, hey, here are my threads waiting. Where are my threads waiting? Why are they waiting? All this sort of stuff. Super, super useful. So you need to get used to this. All right, now let me see, because I wanted to go back to my presentation. There's a couple of thoughts I have, because, I haven't, previously I thought maybe I've been lying to you, because, the thing is, we just now load tested one endpoint. So we had a Spring Boot application. It was my text controller endpoint. And yeah, it returned JSON, which is fine. And we got this one absolute number back where we said, yeah, I don't know, remember 7,500 requests or 5,000 requests per second. This is what my endpoint can do. And we're always fixated with these, absolute numbers, saying, 5,000, 10,000 numbers. But I mean, the reality is that obviously what you need to test in real life is really user journeys. It's not like that there's just one endpoint, the password reset endpoint, and you just want to hammer this one endpoint. Rather, you obviously want to, whole load test, understand how does the user navigate, what are my hot paths, and, obviously load test these hot paths. Make it a bit more realistic, not just one tiny endpoint, and then off you go. But there's one tiny but. I put Stack Overflow here. Let me just quickly go back to a browser. I wanted to show you something. So Stack Exchange, which is basically the platform which includes Stack Overflow and all the other exchanges, publishes their performance numbers. And when you scroll down, what you can see is, I'll scroll down here, they have 9 web servers. And on the left, what you can see here is that they say, it's a round number, so take it with a grain of salt, but they say on average, they have 300 requests per second. And the peak is 450 requests per second. And yes, we don't know what these requests do and what they're there for and whatever, but still, Stack Overflow is one of the most visited pages on top 100 or whatever, or the Stack Exchange platform. And if they have 300 requests per second on average, it's not like you and your internal business software are going to have 300 requests per second on average, or 1,000 or 10,000. Excuse me, just a second. Rather, your application will have much, much lower requests per second, because think about it, it would be like 300, 300, 300, 300, 300. And most people will be happy to have these request numbers in the tens. Yeah, so like 10 consistently is also a lot of traffic for a lot of applications I've built, certainly. So you don't need to worry about being able to handle 10,000 requests or 20 or 50,000 requests, unless you're like a company like Alipay, the Chinese payment provider, which they have crazy numbers. But for mere mortals, just to set you into perspective. Right. So this is one point. The second point is, as I mentioned already, the whole infrastructure test. Obviously, that was a very simple example, one Spring Boot application. Most applications will obviously use a database or a network queue or whatever have you, and microservices. And then the interesting thing is, what you need to do is you need to do what I just did against this one tiny box, and then across the whole ecosystem of your whole microservices. And what you want to do is you want to find out stuff like the weakest link. So who is the weakest box, so to speak. It doesn't help if you auto scale 5 microservices to 10,000 requests per second. If there's something in the back which can only handle 100 requests per second. It will just make things worse, actually. So you want to find out who's the weakest link. And there's actually tools like, which is a super awesome evolution, so to speak, distributed flame graphs, where you can actually, create flame graphs across all of the participants of your load test microservices, and then combine them into one big, huge flame graph. I'll show a link of that in a second. And last but not least, expectation management. So the thing is, and this is has nothing to do with Spring Boot, so to speak, but more with life and business people. As we already mentioned with Stack Overflow, normal life is pretty normal for most people. And you literally will not have 10,000 of users tomorrow, and you will not be the next Amazon tomorrow just overnight without you being able to adapt. And there might be not even the biggest platforms like Facebook did that when you look at the initial growth graphs. I had a chat with my good colleague Marit, who worked at Bol, the Dutch Amazon, so to speak. And she also then mentioned that the interesting thing is, for her, not even Black Friday, because Black Friday was an expected load increase where a ton of people just said, okay, we need to buy something, but you knew it in advance because you knew the day will come. But she said the craziest thing that she encountered was the sale of the PS5, where people hammered the page, to get a PS5. That was crazier than any Black Friday she saw so far. And that is just, a tiny anecdote for you in terms of expectation management that I wouldn't have thought of. It could be so crazy, but yeah, in general, you need to, what I wanted to say is push back on, crazy expectations. If someone comes to you and says 10,000 users tomorrow, and you only have, you haven't even launched, then you don't need to make sure that your server will be able to handle 10,000 users per second. But with all the tools I showed you and the process roughly, and hopefully, collecting the data and analyzing the data, you should be able to get a pretty good understanding of the application, how much it will be able to handle, and how it will affect CPU usage, memory usage, and how much buffer that will leave you on a given machine. And that hopefully in total should, give you the confidence to not worry about scaling your Spring application anymore. Let me see. Before we completely finish off further reading, if you want to, replicate, do some more reading and also play with some code. The code you saw me execute lives under the first line here, the repository. You can see Marco Behler, high performance Java. You can simply search for it. You'll find it. And then you can execute the code yourself. You can actually reuse it with your own scenarios, and even, send me an email or Twitter tweet or whatever have you if you have problems, setting it up. The Chatty Performance project, which I talked about earlier, this framework, this load testing framework, I'm simply reusing. You can find it here, the Chatty Performance, the Chatty project, Chatty Perf. And then there's a fellow Christoph. I can't say his last name right, unfortunately. There's a link here. He wrote an insanely good article about async profiling, about flame graphs, understanding them, understanding performance bottlenecks, how finding out, what I just mentioned, how applications perform. I can, he is really good, and it's a super good manual if you want to get into this performance-aware programming, bottleneck finding ecosystem, or universe rather, or rabbit hole. Let's call it a rabbit hole. Last but not least, if you want to find myself, Marco Behler on Twitter, Marco Codes on YouTube, or in written form, marcobehler.com, my own website. And that leaves me with a big thank you. Thank you for listening.
Wow. Thank you, Marco. That was fantastic. I honestly had so much fun listening to that. I thought it was fascinating. And I, in particular, love the part where you got to the pet clinic application, because it's an application that I've used it, and it's always like you're just showcasing it as a demo, and it's just kind of exciting to dive into something that you've used before.
Absolutely, yes,
Go
yes.
on this mystery ride.
Yes, and there's the thing is, and this is just a 1 hour talk, but again, we haven't even touched. Usually, in real life applications, you would see all these, SQL statements take up a lot of time, for example, and PEC didn't do any of these SQL statements or execute them. Even there, you couldn't see them. But there's actually what I just mentioned. It's a huge rabbit hole, and PEC was already, nice to see, as you just said, a real application we all kind of know and how it kind of performs. And then you can literally spend weeks and months analyzing what even just Packlink or bigger applications do. So
Yeah, exactly. And it's funny because I was thinking a little bit like your title. When I first read your title, before even reading the abstract, I was like thinking, well, maybe this is a talk about Kubernetes, just scale horizontally. Don't worry about what's in there. But actually, it's like the opposite. I thought at the beginning, I was like, he's going to take a weight off your shoulders. You don't have to worry about your app. But now, actually, you have to worry about the million things that Spring brings in.
Exactly, it's the opposite of just
opposite.
adding more pods. Yeah, it is.
So sorry, I thought this was a stress reducing talk. This is a stress intensifying talk, but with the tools to deal with the stress.
Exactly. Yes. Yeah.
I also think like the other fascinating thing about this is that you can learn so much, right? You go into the weeds and you realize, where are those OS calls? What are these specific technologies doing?
Yes.
Yeah, and it really makes you appreciate how Spring integrates everything and just puts all these things together for you.
Absolutely. So, and this is what you also, when I talked about Thymeleaf, the thing is, Thymeleaf, takes a lot of CPU. It also, offers you many things. So it's a nice templating language, but still, usually programmers aren't aware of, what tool library could be CPU intensive, memory intensive, or let's say they're not aware of all these performance characteristics across the whole board. And with actually to be able to get the data, even the operating system data and the kernel data, as you mentioned, is not even so. These kernel calls, you can actually look them up online and you'll understand what they do. And it's interesting because as a Java programmer, you're always so far removed from these lower level things, but it's all there. You can access it.
Yeah, it's good to know though, because you could spend a lot of time sort of like troubleshooting one area, and that's not where your delay is at all. Yeah, very cool. I loved it. So okay, let's get to the questions.
Cool.
So we have viewers. I'll put them on the screen and then see if some of them are. Sometimes we might ask people to clarify some things, but Romulo Santu says, how do you see the growth of Go, and how does you don't have to, you can you don't have to answer this. It's a big question.
Right.
But if you have any thoughts.
I actually have no good idea on that. I try to stay out of these programming language ecosystem battles. So I don't have a good answer. Sorry.
That's fair. That's what I thought. Maybe that would be the case. I wouldn't know what to say. We do have some, folks saying Simon Verhoeven saying, looking forward to this one. That was early when you were starting, and asking which JDK you would be using. I don't remember if you mentioned that. Yeah.
So the server was running, or pretty much all the machines were running JDK 11, if I'm not mistaken, or it could be JDK 11 or 17. Either of these two. So one of these two. Sorry. Yeah.
Okay. All right. We have a question from Anbu Sampath asking how many threads were configured in Tomcat.
Actually, so the ones I wasn't using Tomcat, I was using Jetty, and it was just the defaults. And I'd have to look it up at the moment. But then again, what you need to realize is that what actually Jetty does internally, there's no, one thread handles one request mechanism. It's all done, asynchronously and super hyper optimized under the hood. But that is actually a fairly long topic to get into.
For another talk.
Yeah, for another talk.
Another talk. All right. Gabriel Fairbanks is asking, why not use Gatling instead of the custom loaders?
Yeah, there's so the real answer, my honest answer is, I mean, in the past I've worked a fair amount with JMeter, which I personally was never a super big fan of, if I'm allowed to say that. With Gatling, I don't have the super much experience. I used it once, professionally, so to speak, a longer while ago. And there's no specific reason other than that the Jetty guys helped me out so much, and they had this framework already available, and it's super simple to reuse. So I just reused it, and yeah, that's it.
Fair. We have, let me find the questions here. Here's a question from Ashutosh Kumar asking if you have some recommendations about starting to learn backend with Java for a beginner.
That's also that is a very broad question. I don't have a good answer.
I can help you out a little bit.
Yes,
actually.
please.
Yeah, because so I would do this later, but I'll do it now. But we have there's a website called Spring Academy that we just launched actually here at VMware, and so it's got a lot of free information on learning classes, and even a path to certification if you're interested in that. But a lot of free material for learning Spring, including, of course, backend stuff. So that would be one place to start. So that's one.
Give it a go.
Yeah, exactly. Yeah. I also know we have, just to plug some, Dan Vega's on, I know he's here in the chat. I see him. He gave you props for Marco Codes. He's obviously a fan of your YouTube channel. Dan Vega.
I'm also a fan of his.
Oh, good. So I was going to say, you can go to Marco Codes channel, of course, and Dan Vega has a lot of material as well from our team. Both Josh Long, Dan Vega, and Deshaun Carter put out a lot of material for learning Spring. So other folks you can follow as well. And let's see, let me find the other questions here. I think this is just, I think Ashutosh is asking a follow-up question, but I think we covered that. Okay, let's see. We're going to share your slides, right? Vince is asking, he wants the links to your material. So
you'll get the links.
Yeah,
yes.
Those will be, the recording of this talk is also available, so you will be able to look that up and pause on that slide as long as you need. We have a question from Vince. Any comment on free marker usage instead of time leaf? Anything additional that you want to say beyond what you said?
I mean, the thing is, and hopefully none of the time leaf maintainers, watch this and then give me this. I was comparing apples and oranges, but the thing is, I mean, both are templating libraries, and ThymeLeaf has to do more work than FreeMarker, and FreeMarker is more on the side of simple text replacement, whereas ThymeLeaf is more on the side of you have a proper HTML page and ThymeLeaf parses it, and it's not just text replacement, so to speak. And I personally have worked a lot with FreeMarker also in the past. I mean, a long time ago. And in general, I'm more of a fan of how ThymeLeaf templates turn out to be, because FreeMarker templates, if you really watch out, then they will have 20 million custom functions and all sort of crazy stuff, and then it's unmaintainable. But that is my talk on it. I mean, Velocity, FreeMarker are both nice templating libraries. ThymeLeaf is kind of the default, but still you need to be aware of the performance penalties or performance issues and take them into account, and maybe choose one of the others, one of them based on performance also.
Awesome. So there's no more questions here, but I will tell you that several people are saying thank you. Simon Verhoeven, O'Clyde Reeve, we have here by Voila, Claudio. I hope I'm saying everybody's names right. I don't know. Love the presentation. Very clear and on point, Marco. So I want to thank you as well. But I also, just before we go, I want to also remind people, besides checking out Spring Academy, we also are gearing, this is the golden path to Spring 1, which will be side by side with VMware Explore this year. So we hope to see you in Las Vegas in August. We're really excited about that. And beyond that, I think we've covered all the comments. I think it was a really fascinating presentation. I sincerely had a lot of fun watching it, Marco.
Cool. Thank you,
So
Cora.
thank you. Yeah, and I know that you're a little bit under the weather, so we're really extra appreciative of you, showing up today and doing this for us.
You're welcome.
Great. So, okay, everybody. So see you next Tuesday will be the next session for the Golden Path to Spring One.
Bye, people.
Right.
Thank you.
Bye-bye.
Bye.